Good morning, ladies and gentlemen. Can anybody hear and or see me? Am I coming through?
Good morning, Professor.
All right, good morning. Well, I sent the quiz out yesterday. It will be due by tonight, midnight, the chapter 2 quiz. You can work the problems out on the quiz if you want. If you want to work them out on separate paper, you can. Just make sure you put the name of the assignment at the top of the paper. That's all that I ask. And as always, I do appreciate when you email me any document that in the subject line, you indicate what document that is. That really speeds up my ability to sift through all my emails. I do appreciate that. I will, after this session, get the chapter 1 and 2 exam together and get it to you guys. That will be due by tomorrow night, midnight. And I will also email you and indicate to you what I want you to send me for proof of having done the chapter 1 and 2 homework. So just stay tuned on that very important email. All right, ladies and gentlemen, we are going to embark on a new chapter here this morning, chapter 3. 3.1 is going to introduce us to a very important concept called a reference angle, of which we will be using throughout the rest of this course here. So 3.1 is on the docket for today.
Professor,
Yes.
I noticed that the meeting's being recorded. Is that on purpose? Are you recording them now?
Well, I'm going to try to record this meeting and see if it works.
Okay.
In the past,
Awesome.
I'm going to try to get in the habit of doing that. My computer sometimes acts like a Commodore 64 computer. You know, I don't know if any you people are probably a little too young to remember the Commodore 64, but that was the first computer I've ever owned in my life. Back in 1982, I bought a Commodore 64 computer at Toys R Us, and it had like 64K memory. And I thought I was
Toys R Us? That's awesome.
Yeah, I thought I was on top of the world too in 1982 with that machine, you know.
64K memory.
64,000 bytes of memory. Man, I had it made in 1982, you know. And I started to learn how to computer program on that simple machine. And then it went from there. But yeah, the Commodore 64 is where I began back in 1982. So that's really showing my age. If my gray hairs don't show my age, that is definitely doing the job. But it's amazing how far we've come since 1982 with our computer technology. It really is mind-boggling. Now we got computers that can do, can perform like trillions of calculations per second, you know, trillions of calculations per second. It's just hard to believe. All right, so section 3.1 is aptly entitled reference angle. And this concept of a reference angle is going to enable us to evaluate our trig functions for any angle in the XY plane. So what is a reference angle? And a good place to start is, of course, to define a reference angle. So this is a definition to get us going here. So a reference angle, and it's going to be denoted symbolically as theta prime, okay, for an angle theta is the smallest positive angle formed by the x-axis, always the x-axis, not the y-axis, formed by the x-axis and the terminal side of the angle theta. So that's the definition of a reference angle. Right now, it's probably as clear as mud in our minds, unless, of course, you went over section 3.1 before you came to class this morning. Probably has some relevance then. This is a well-known fact. Every angle has a reference angle. So every angle has a reference angle. All right. If, ladies and gentlemen, theta is a first quadrant angle, then the reference angle theta hat, this little symbol is called the hat symbol, theta hat, which is the reference angle, is actually the angle theta itself. That's always true. So let me draw a picture to illustrate what that is saying. So if you have your XY plane here, and you have a first quadrant angle in standard position, if this is theta, then, ladies and gentlemen, the reference angle happens to be theta hat, which is also the same angle as theta. So first quadrant angles, their reference angle literally is the angle itself. Notice the reference angle is formed by the terminal side of theta and the x-axis. If theta is a second quadrant angle, then as it turns out, the reference angle to a second quadrant angle is always going to be 180 degrees minus theta. And to illustrate an example of that, here's your XY plane. If theta is an angle in the second quadrant in standard position, let's say it's the angle right here, there's theta. The reference angle is almost going to be this positive little angle right here, theta hat. And theta hat, this angle here is going to be 180 degrees minus theta. Notice the reference angle is formed by the terminal side of the angle theta and the x-axis. Any questions so far? All right, do we have this definition of a reference angle down here? I need to get rid of it here. Okay. What if we have a third quadrant angle? If theta belongs to the third quadrant, what would be its reference angle? Well, then the reference angle of a third quadrant angle would be the angle theta minus 180 degrees, always. Here's your XY plane. We have a third quadrant angle in standard position. So this is angle theta. Then the reference angle would be this little small angle right here. That would be the reference angle, theta hat. And notice theta hat's measurement would be the angle theta subtracting off 180 degrees. That'll leave you with theta hat's measurement. And notice the reference angle again is formed by definition by the terminal side of the angle theta and the x-axis. Okay. All right, do we have this page accounted for here? Right there. All right, one last situation, of course, is what happens if theta is a fourth quadrant angle? What would be its reference angle? Well, if theta is a fourth quadrant angle, then the reference angle theta hat is always going to be 360 degrees minus theta. So if we have a fourth quadrant angle in standard position, that's angle theta. The reference angle is going to be this little positive angle formed by the terminal side of theta and the x-axis. That'll be theta hat. And its measurement will be 360 degrees minus theta. All right, so that's the way it works for any angle. You can always find a reference angle. And you'll see the utility or the reason why it's nice to find a reference angle. in the moments to come. Okay. So any questions on this concept of a reference angle so far? All right, now the argument so far this morning has been general. It's been abstract and general. Let's get down to the nitty gritty and look at some specific examples. So ladies and gentlemen, here's some examples here. If theta is a 65-degree angle, then what would be its reference angle, theta hat? Anybody? What would be the reference angle? So we have a 65-degree angle, which is theta, and that's in the first quadrant. What would be the reference angle to the 65-degree angle? Anybody want to take a guess? Based on what I just showed you? Well, the 65-degree.
I'm still lost, Professor. I'm sorry.
The 65-degree angle is a first quadrant angle, correct? And anytime we have a first quadrant angle, the reference angle is always the angle itself. All right, so therefore the reference angle to the 65-degree angle is going to be 65 degrees also. That'll be the reference angle. So a first quadrant angle is also its reference angle. It's always true. Another example, suppose theta is a 120-degree angle in standard position. What would be its reference angle? Well, 120-degree angle is in what quadrant? In standard position, that finds itself in the second quadrant there.
Would it be 60 degrees?
That's correct. The reference angle would be this small positive angle formed by the terminal side of the 120-degree angle on the x-axis. That would be theta hat. And we just seen over here, ladies and gentlemen, that if we have a second quadrant angle, the reference angle is always 180 degrees minus the angle. All right. So therefore, the reference angle to this 120-degree angle is going to be 180 degrees minus 120 degrees, which means our reference angle will be 60-degree angle, 60-degree angle. So this little angle here is the reference angle to that 120-degree angle. That'll be 60 degrees. Does that make a little bit more sense now? So the reference angle to 120-degree angle is 60 degrees.
Okay, yeah, I see it.
All right, suppose we have a angle theta that's 200, that measures 210 degrees, then what would be the reference angle? Well, 210 degrees in standard position puts our angle theta in the third quadrant down here. What would be the reference angle? The reference angle would be this small positive angle formed by the terminal side of theta and the x-axis.
30 degrees.
And that would be 30 degrees, because if we have a third quadrant angle, which theta is, okay, the reference angle for a third quadrant angle is always the angle minus 180 degrees. Okay, that's the reference angle for a third quadrant angle. So therefore, for a 210-degree angle, the reference angle is going to be 210 degrees minus 180 degrees, which you are correct. It would be a 30-degree angle. So this little angle here is called the reference angle to 210 degrees. It's 30 degrees. Finally, for an angle that measures 315 degrees, what would be the reference angle? Well, 315 degrees would be an angle in the fourth quadrant. Right here. That would be a 315-degree angle. And the reference angle to a fourth quadrant angle is always going to be 360 degrees minus the angle.
45 degrees.
That's what it would be. That's right. So the reference angle is going to be 360 degrees minus 315 degrees, which means the reference angle will be a 45-degree angle. So the reference angle is going to be right here. That'll be a 45-degree angle. And notice the reference angle always is formed by the terminal side of an angle in question and also the x-axis, always the case. All right. So far I've given you reference angles for positive angles in standard position. Do you think negative angles have reference angles? True or false? A negative angle has a reference angle. What's the answer? True or false?
True.
True. Every angle, ladies and gentlemen, I don't care if it's a positive angle or a negative angle, has a reference angle in the XY plane. That's always true. All right. So let's look at this one here. Oh, look at, here's a trick question. What would be the reference angle for a 90-degree angle? Anybody want to take a stab at that? A 90-degree
90 degrees.
Yeah. The reference angle of a 90-degree angle, by definition, a reference angle is formed by the terminal side of the angle and the x-axis. So the reference angle would also be 90 degrees. All right, let's look at a negative angle. Suppose we have an angle that measures, let's say negative 150 degrees. What would be the reference angle of a negative 150-degree angle? Well, again, always try to get a visual on things. Try to, sketch a picture in the XY plane of your angle. That helps immensely with all problems in trigonometry. So negative 150 degrees would be in what quadrant? It's negative 90 degrees. And then we have to rotate another, what, negative 60 degrees. So that would be a negative 150-degree angle in standard position. So it finds itself in the second quadrant. And ladies and gentlemen, for an angle that's in the second quadrant, its reference angle is always what? For a second quadrant angle, the reference angle is always 180 degrees minus theta. Well, let's see if that holds true here. 180 degrees minus theta. Now, this is a negative angle, not a positive angle, correct? All right. Negative angles are a little bit different as far as finding reference angles as opposed to what I laid down. Whoops, what I laid down here. All these were considered to be positive angles in the various quadrants here. Okay. Tell you what, ladies and gentlemen, it's not that difficult to generalize this to negative angles also. What do you think this little angle has to be here? What does that little positive angle have to be? Formed by the terminal side of the angle and the x-axis. It's not too difficult to see. If here to here is negative 150 degrees, how many degrees does this have to be here? If
30?
we know from here to here is negative 180, correct? If we know from here to here is negative 180. What does this angle have to be then if we have a negative 150-degree angle?
30 degrees.
30 degrees. You're correct. Remember, it's got to be a positive angle by definition. A reference angle is the smallest positive angle formed by the terminal side of an angle and the x-axis. So this would have to be a 30-degree angle. So the reference angle of a negative 150-degree angle is a 30-degree angle. That's the reference angle right there. Everybody see that there? Okay. All right. So what is the point, of these reference angles? I mean, is it just here to, further clutter up our minds, ladies and gentlemen? What's the usefulness of these reference angles? Well, here's the usefulness. There's a theorem in trigonometry. It's called the reference angle theorem. And a theorem in mathematics, ladies and gentlemen, is a valid, proven statement in mathematics. The entire field of mathematics, which is a large field, rests upon a whole bunch of proven theorems. These theorems were scrutinized by brilliant minds down through the annals of time. I would like to think that my mind's one of those that contributed to this, but I can't say that, ladies and gentlemen. I'm standing on shoulders of giants. in saying this. I'm just here to, relay the information to you. I never came up with a theorem in my lifetime. Ostermeyer's theorem. I mean, you won't see that anywhere. Still working on it, but yeah, theorems are proven statements in mathematics. And if you stay in math long enough, and eventually, usually your fourth year in a university or your first year in graduate school, you'll start to learn how to prove theorems, how to write proofs in mathematics. Okay, so this reference angle theorem says this, ladies and gentlemen, for any angle theta, positive or negative angle, doesn't matter, the sine of angle theta is equal to the positive or the negative sine of the reference angle to angle theta. Now, why do I have positive or negative? Well, it depends upon what quadrant angle theta lies in. That will dictate whether you have the positive or the negative of the sine of the reference angle to angle theta. And that's true with all your other trig functions. The cosine of this angle theta would be equal to the positive or the negative of the cosine of the reference angle to angle theta. Likewise, the tangent of angle theta would be equal to the positive or the negative of the tangent of the reference angle to angle theta. And all the other ones follow suit. Cosecant of theta is the positive or the negative of the cosecant of the reference angle theta hat. Secant of theta is equal to the positive or the negative of the secant of the reference angle theta hat. And finally, the cotangent of angle theta is equal to the positive or the negative of the cotangent of the reference angle theta hat. So this theorem guarantees that this is always going to be true. This reference angle theorem, okay, always guarantees that that will be true there. Okay, and I'm going to try to illustrate this what this reference angle theorem is saying with an example, because right now it's somewhat abstract. A lot of theorems in mathematics are very general statements, abstract statements, and usually to understand theorems, it's good to look at an example that supports the theorem. That's how I learn math, is by looking at a lot of good examples. So my saying in mathematics is, show me a good example and I'll understand what's going on. Okay, so this reference angle theorem is pretty nifty in a way, you'll see, because to evaluate any trig function of any angle theta, it's equivalent to as if we evaluate that trig function for the reference angle to that angle. And oftentimes evaluating the trig function for a reference angle is so much simpler than evaluating the trig function for the angle itself. All right. Okay, so let me try to breathe life into you what this reference angle theorem is saying with an example. We all have that accounted for there. Okay, so let's show ourselves an example. So XY plane. Suppose we have a 30-degree angle. Suppose that we have a 30-degree angle here, and hold on a second. I'm going to try to keep this this balanced here. This will be 30 degrees also. And down here, this will also be 30 degrees. And right here, this will also be 30 degrees. Okay, do we understand the picture so far here? All right, of course, if we have a 30-degree angle in standard position, which is a first quadrant angle, you can build that reference right triangle we indicated in the past, and we really have a 30, 60, 90 triangle. And suppose the length of the side opposite 30-degree angle is of length 1 unit. Well, that means the hypotenuse, being always twice the length of the shortest side of a 30, 60, 90 triangle, would have a length of 2 units. And this side opposite the 60-degree angle would have a length that's a square root of 3 times longer than the length of the shortest side. So this length here, the X side length, if you will be the square root of 3 units in length. So on this point up here would be what point? What would be the X coordinate of this point up here? The X coordinate. The X coordinate would be
1, 2.
Well, it'd be the X coordinate would be
Root 3.
square root of 3 would be the X coordinate, and the Y coordinate would be what? Positive 1 then, correct? The Y coordinate would be 1. That makes sense for that point there? All right. Now, what would be this point on this angle here? This angle here would be 180 minus 30 degrees, or this would be a 150-degree angle here in standard position. Well, as it turns out, the ordered pair would have the same coordinates as this ordered pair. It's just that the signs would be a little different because we're finding this point in the second quadrant. So this ordered pair's X coordinate would be negative square root of 3, and its Y coordinate would still be 1. By the time we get down here, now our point is in the third quadrant, and that would pertain to an angle that measures 210 degrees in standard position, 210-degree angle whose reference angle is 30 degrees. This point down here, because the points in the third quadrant, would have an X coordinate of negative square root of 3 and a Y coordinate of negative 1. Finally, by the time we get down in here, our fourth quadrant angle would have a measure of 330 degrees in standard position, whose reference angle is 30 degrees. And this point on the terminal side of this 330-degree angle would have an X coordinate of the square root of 3 and a Y coordinate of negative 1. All right, now by looking at this illustration, ladies and gentlemen, we can begin to dig into this reference angle theorem here. So what would be the sine of 30 degrees? Well, the reference angle of a 30-degree angle would be what? Would be the angle itself. Do you agree? Because 30 degrees is in the first quadrant. So the sine of 30 degrees would be what ratio? Sine of 30 degrees is opposite side divided by the hypotenuse side, correct? So it would be positive 1/2. Now, what would be the sine of 150 degrees? Well, ladies and gentlemen, what is the reference angle to a 150-degree angle? What's the reference angle? 150 degrees is in the second quadrant, correct? 150-degree angle right here in standard position. What's its reference angle? Its reference angle is 180 degrees minus 150 degrees, which is 30 degrees. So the reference angle is 30 degrees. So ladies and gentlemen, I claim that the sine of 150 degrees is either equal to the positive or the negative of the sine of the reference angle, which is 30 degrees. But we already did the sine of 30 degrees, it's 1/2. But would it be positive or negative? Positive or negative 1/2 if we're talking about a 150-degree angle? Well, we're in the second quadrant because we have a 150-degree angle. So the sine of a second quadrant angle, all students take calculus, all students, S for sine, the sine would be negative. So the sine of 150 degrees is equal to the negative of the sine of the reference angle to the 150-degree angle, which is 30 degrees. So the sine of 150 degrees would be negative 1/2. What would be the sine of 210 degrees? Well, what's the reference angle to 210 degrees? The reference angle is 210 degrees minus 180 degrees. The reference angle would be 30 degrees. So for this 210-degree angle in standard position here to here, the reference angle is 30 degrees. So the sine of 210 degrees would be, again, the positive or the negative of the sine of the reference angle to 210 degrees, which is 30 degrees. Would it be positive or negative 1/2? Since we're in the third quadrant, the sign of a third quadrant angle is always positive or negative. All students take T for tangent and cotangent are positive in the third quadrant. All the other trig functions are negative. So this would be negative. So the sine of 210 degrees would be negative 1/2. Finally, the sine of 330 degrees would be the positive or the negative of the sine of the reference angle to 330 degrees. 330 degrees being this angle right here, and its reference angle is 30 degrees. Since we're in the fourth quadrant, would this be positive or negative 1/2? Positive or negative? Fourth quadrant, all students take calculus. Calculus, C for cosine and secant are positive in the fourth quadrant. All the other functions are negative. So this would have to be negative. So it'd be negative 1/2. So that's basically what the reference angle theorem is guaranteeing, ladies and gentlemen, is that the sine of any angle, even if it's an obtuse angle, okay, is always equal to the sine of the reference angle to the angle. And that's true for all the other trig functions, the cosine, the tangent, the cosecant, the secant, and the cotangent. It's always true. Well, that's the idea that's being pushed in section 3.1. Okay. Any questions about that? Okay, let's do maybe a couple problems in our textbook now. And like I said, another way that I learned math well is by doing the textbook homework. It's through the textbook homework you basically gauge where you are with your understanding with the material. So homework is critical. And there were times that when I felt that I needed more practice, even above and beyond what my textbook afforded me, in which case I would then go to the library and dig out more math books and, entertain more problems of the same type. Kind of sounds strange to say go to the library, because we live in this age, this digital age where we have everything at our fingertips online. But libraries are still, I don't know, they bring back a lot of good memories for me. But, okay, suppose you want to find the exact values of a couple of these things here. How about the cosine, ladies and gentlemen, of 210 degrees? Now, since I want the exact value of the cosine of 210 degrees, I do not want you to get on your calculator, because your calculator is just going to give you a decimal approximation. I don't want that. I want the exact value. And so here's what we need to do. We need to, okay, picture this angle. Please draw a picture. Just a sketch. It doesn't have to be really, neat and everything. Just, sketch it out. 210 degrees in standard position is in what quadrant? 210 degrees. What quadrant would that be in?
Third quadrant.
All right, third quadrant. So that's like right here. Okay. So there's our 210 degree angle. But ladies and gentlemen, I want the cosine of 210 degrees. So I have a question for you. What would be this reference angle here? Right here, the smallest positive angle. What would be theta hat?
30.
30 degrees. Yeah, it'd be 210 degrees minus 180 degrees, which would be 30 degrees. So our little reference angle would be 30 degrees here. So 30 degrees. And now watch this. If I build a reference right triangle by bringing a perpendicular up to the x-axis, I really have my what right triangle? What special right triangle is this? It's the what
30,
right?
60, 90.
Yeah, there you go. I mean, it's our old friend, the 30, 60, 90 triangle. Everybody see that there? And ladies and gentlemen, because we have the 30, 60, 90 triangle, we can label the sides based on what we've seen in the past. Normally, I call the side opposite my 30 degree angle the side that has a length of 1. But look at careful. We're in the third quadrant, so it would not be positive 1, but it would be what? Negative 1. All right, that'd be kind of like your y side. Your x side would be what? This is the side opposite the 60 degree angle, which is always the square root of 3 times longer than the length of the shortest side. So the square root of 3 times 1 is the square root of 3. But since we're in the third quadrant with our angle, the x side would be negative also, negative square root of 3. And the hypotenuse, always being positive, r, would always be twice the length of the shortest side. So twice times 1 is 2. Look, I've labeled the sides of my 30, 60, 90. Now we're in business. So the cosine of 210 degrees, ladies and gentlemen, since our angles in the third quadrant, excuse me, would be equal to the negative of the cosine of the reference angle 30 degrees by the reference angle theorem. So the cosine of 200,
Professor,
what's that?
I have a quick question. I thought when you're in the third quadrant, it was angle minus 180 degrees, and I thought the second quadrant was 180 degrees minus the angle. Am I getting it backwards?
No, that is correct. I did do that over here. The reference angle of 210 degrees would be 210 degrees minus 180,
Okay.
30 degrees.
Okay.
That's
Okay.
a
I just
little-
was looking at it backwards.
Yeah, that's a little
Okay.
30-degree angle right there. Okay.
Thank you.
So ladies and gentlemen, since this angle's in the third quadrant, the cosine of 210 degrees would be the negative of the cosine of the reference angle to the 210 degree angle, which is 30 degrees. So what's the cosine of 30 degrees? Well, cosine is what ratio? So CAH, adjacent side over hypotenuse. So that would be negative square root of 3 over 2. Negative square root of 3 over 2. And we're done. There's your answer. So the cosine of 210 degrees in exact form is negative square root of 3 over 2. So these reference angles, ladies and gentlemen, are going to enable us to find the trig functions of any angle now, where we don't even have to use a calculator necessarily. Not for this problem, because we had a nice triangle here. Maybe we could, I don't know, try another one. What would be the tangent of 315 degrees? In exact form. Leave your answer in exact form. So no decimal approximation. So I don't want you to get on your calculator. So let's try to graph the angle in standard position. 315 degrees would have our angle terminate in the fourth quadrant down here. So that would be theta, 315 degrees. So ladies and gentlemen, if our angle is 315 degrees, what would be the reference angle? Because it's a fourth quadrant angle, that would be 360 degrees minus 315, which would render our reference angle as being, the magical angle, 45 degrees. So our little reference angle is a 45-degree angle here. Building a reference right triangle by bringing a perpendicular up to the x-axis, we have our special right triangle, which is the 45, 45, 90 triangle. And ladies and gentlemen, since we have the 45, 45, 90 triangle, we know the side lengths are of ratio 1, 1, square root of 2, correct? Your x side is of length 1, your y side is not positive 1 because we're in the fourth quadrant, so y is negative 1. The hypotenuse would have a length that is positive square root of 2. Now we can answer the question, because we know the tangent of 315 degrees is equal to the tangent of the reference angle, which is 45 degrees. But since our angle is in the fourth quadrant, the tangent of a fourth quadrant angle is positive or negative. All students take calculus. C for cosine and secant are positive, all the other ones are negative. So this would be negative. So the tangent of 315 degrees is equal to the negative of the tangent of the reference angle to 315, which is 45 degrees. And the tangent of 45 degrees is going to be just what? It's opposite over adjacent. So it'll be 1 over 1 or 1. But since we're in the fourth quadrant, the answer would be negative 1. There you go. So that's what the tangent of 315 degrees will be in exact form, is negative 1. So it's this idea of trying to get used to using the reference angle of an angle to evaluate in exact form these trig functions here. Is this making any sense here, ladies and gentlemen?
I have a question.
Yes.
Are we ever gonna be in a situation where we don't have a 30, 60, 90 or a 45, 45, 90?
Yeah, there will be instances, and there will be a couple of problems out of this section where you'll have that situation. In that case, if you don't have, your nice triangle, like your 45, 45 or your 30, 60, 90 triangle, then you would have to just give like a decimal approximation using your calculator. Okay.
Okay, could we do one of those maybe?
Yeah, like if you had, let's look at like the secant of, let's say like 115 degrees here. The secant of 115 degrees. Now, 115 degrees would find itself in what quadrant? In standard position. That would be in right here in the second quadrant there. That's what theta would be. What would be the reference angle to this angle? So the reference angle of 115 degrees would be, how does that work? 180 degrees minus theta. So 180 degrees minus 115. So that would give us a reference angle. That is what? Is that
65.
I believe 165 degrees. So the reference angle would be, wait a minute, not 165. Sorry, it'd be 65. Okay. All right, so the reference angle would be 65. So by the reference angle theorem, the secant of 115 degrees is going to be the positive or the negative of the secant of 65 degrees. And since we're in the second quadrant, all students, so students S for sine and cosecant are positive in the second quadrant, all the other ones are negative. So this would be the negative of the secant of 65 degrees. And so then you would basically, just get on your calculator and take the secant of 65 degrees, but we don't have a secant button on our calculator, so we would have to use our reciprocal identity and calling this -1 over the cosine of 65 degrees. And then what would this approximate to? If we were to take that out to like 4 decimal places, that would be -1 divided by the cosine of 65. Make sure you're in degree mode on your calculator. And so I'm getting like -2.3662. Okay, so that'd be an example where you just have to use your calculator. Does that make
Thank you
sense?
for doing that, yeah.
Most of these are going to render themselves to the nice triangle, 30, 60, 90, or the 45, 45, 90 triangle, though. Most of them will. All right. How about the cosine of 420 degrees? And the answer is to be in exact form. Okay, so we want our answer to be in exact form. Well, 420 degrees is going to be an angle in standard position in what quadrant? Well, 420 degrees is going to be one trip around, correct? Which is 360 degrees plus some change. So to find out how much change we have left, take 420 degrees, subtract off 360. That gives us 60 degrees of the more change. So if we go around one whole time counterclockwise, that's 360 degrees plus 60 degrees more, would have our 420 degree angle finding itself in the first quadrant. So therefore, our 420 degree angle is in the first quadrant. So later on, what would be the reference angle of this 420 degree angle? What would be this little reference angle theta hat here? Well, anybody want to weigh in on that? What would be our reference angle to this 420 degree angle here?
It's 60, right?
60 degrees, yeah, because here to here is 60 degrees. And so this 420, so as it turns out, Liz, on 420 degrees and a 60-degree angle are what type of angles of each other? The word I'm searching for starts with the letter C. Anybody remember that term? These are what type of angles, since they share the same terminal side, they are called?
Complementary?
Well, at least you got the right starting letter for the word. Not complementary angles. These don't add up to
Conjugates.
90 degrees. What are they?
Conjugates.
Not conjugates. They're
Coterminals.
coterminal. There's a word that we used back in chapter 1. They're coterminal angles, because they share the same terminal side. So 420-degree angle is coterminal to 60-degree angle because they both have the same terminal side. So yeah, as it turns out, since 60 degrees is coterminal to 420, the reference angle of 420-degree angle would be 60 degrees. So the cosine of 420 degrees, as it turns out, ladies and gentlemen, is really going to be the positive cosine of the reference angle, which is 60 degrees. Now look at how much nicer it is to deal with 60 degrees as opposed to 420 degrees. You know what I'm saying? And do we remember my little trick I showed you? If we have 0 degrees, 30 degrees, 45 degrees, 60 degrees, 90 degrees. Remember how this worked here? We got 1, 2, 3, 4. Wait a minute, 0. 0, 1, 2, 3, 4. Put all these underneath square roots and then divide them all by what? Remember that trick?
Divide by 2.
All by 2. Cosine is the reverse. So the cosine is 4, 3, 2, 1, 0. Put them all underneath the square root. Divide by 2. This is an easy way to remember the sine and cosines of your nice angles, if you will, that pertain to our special triangles. So ladies and gentlemen, the cosine of 60 degrees, right here, 60 degrees is going to be the square root of 1/2, which is just 1/2. Done. The answer is 1/2. So the cosine of 420 degrees is equal to the cosine of the reference angle to 420 degrees, which is 60 degrees, which is 1/2. So we can really see the reference angle concept shining a little brighter with this example, because the cosine of 420 degrees, I mean, how would you negotiate that in exact form in your mind? Very difficult. But if you know that 60 degrees is the reference angle, it's easy to then realize that we really have our what? Our 30, 60, 90 triangle that we're dealing with. And these sides then would be 1, square root of 3 and 2. Do you agree? So the cosine is the adjacent side, which is 1 over the hypotenuse, 1/2. So that's the idea behind the reference angle, is if you have weird angles, you can still break down the big angle or the weird angle down to a simple reference angle always. And then once you have the reference angle, it's very easy then to evaluate the trig function, because usually your reference angle pertains to one of our nice angles that pertain to one of our special triangles. Okay, so that's the whole gist behind all this this madness here. All righty. So any further questions about that problem there? The cosine of 420 degrees. All right, maybe try another one. How about the cotangent of negative 660 degrees? And I want the answer in exact form. Negative 660 degrees. Well, where would that angle be? In what quadrant in standard position would be a negative 660 degree angle? Well, we start at the positive x-axis and we have to rotate counterclockwise 1 whole rotation, right? Which is 360 degrees.
The second quadrant.
Plus how many more? So look, we got to go around once counterclockwise. That's negative 360. But if we go around twice, that'd be negative 720. We only have negative 660. So what you could do is you could take like 660 degrees and subtract off 360 to see like what kind of change we have left. 660 minus 360 is going to be 300 degrees, correct? So ladies and gentlemen, negative 660 degrees is going to be one complete counterclockwise rotation, which is negative 360. Plus we have to rotate another negative 300 degrees. So there's another negative 90, negative 180, negative 270, and then negative 30 degrees more would put that angle in the what? In the first quadrant. Everybody seeing that there? It's really boils down to a first quadrant angle here. So again, negative 660 degrees is negative 360, negative 360 degrees plus another negative 300 degrees. So negative 360 plus another negative 300 degrees would have us rotating back into the first quadrant. Because negative 360 plus negative 90 degrees plus another plus a negative 180 plus a negative 270 plus a negative 300 degrees would be negative 360 degrees. So it's a first quadrant angle. So it really comes down to then what would be this little reference angle? What would have to be this little reference angle here? Again, think of it this way, ladies. I'm here to here, the coterminal angle to negative 660 degrees is negative 300 degrees. Negative 300 degrees is coterminal to negative 660 degrees because they both share the same terminal side. Now, what positive angle would be coterminal to negative 300 degrees? What would have this be? What would this little angle have to be here? This positive angle. If this is negative 300 degrees, we know
60.
60 degrees, right? That would just be 60 degrees. That would be the reference angle. So you know what? By the reference angle theorem, the cotangent of negative 660 degrees is going to be equal to the positive cotangent, positive because we're in the first quadrant. Our angle's in the first quadrant. The cotangent of the reference angle, which is 60 degrees. Well, look at that. 60 degrees is one of our nice angles. Okay. Cotangent, of course, is reciprocal of tangent. So this is 1 over the tangent of 60 degrees. Well, what's the tangent of 60 degrees? You drop a perpendicular down the x-axis, you build your 30, 60, 90 triangle. This side is 1, this side would be the square root of 3, and this hypotenuse would be 2. The tangent of 60 degrees, ladies and gentlemen, is opposite over adjacent. So it'd be the square root of 3 over 1. So 1 over the tangent of 60 degrees is 1 over the square root of, wait a minute. 1 over the tangent of 60 degrees is going to be 1 over the square root of 3, which after you rationalize this denominator would be the square root of 3 over 3, and we are done. So the cotangent of negative 660 degrees would be really the cotangent of 60 degrees, 60 degrees being the reference angle to negative 660 degrees. Negative angles are a little bit more mysterious, obviously, to work with than positive angles. Do we understand that negative 660 degrees would be an angle in the first quadrant? Because one counterclockwise rotation is negative 360. Negative 360 plus negative 300 more would give us our negative 660 degree angle. So there's negative 360 plus we got to go negative 300 more. Negative 90, negative 180, negative 270, and negative 30 degrees more would be negative 300. Right there. Okay. All right. So negative angles do have you thinking a little bit more so than maybe we are comfortable in doing. So the idea is, yeah, I'll tell you what, it's a heck of a lot easier taking the cotangent of 60 degrees than it is trying to negotiate what the cotangent of negative 660 degrees is. So that's the idea behind this idea of the reference angle business, is to make our life easier, believe it or not. Okay. That's the point. All right. Only one other issue in this section here before I give you your classwork. Suppose that we now ask ourselves how to find an angle. So suppose we want to find an angle theta to the nearest 10th. So we want to round these angles off to the nearest 10th of a degree, where we will assume that our angle theta has to lie between 360 and 0 degrees. Okay. Problem number one, if the sine of some angle theta is equal to negative 0.3090, and we are told that the angle theta must be a fourth quadrant angle, ladies and gentlemen, what would be the angle theta? How have we found angles in the past given a trig function of the angle? Anybody remember how we did that? We used what type of function? So how would I find this angle theta, whose sine is this decimal?
Do the inverse function.
Yeah, so we'll take the inverse sine of both sides of this equation. And the left side of equation is theta. So therefore, we will have to get on our calculator here and take the inverse sine, sometimes called the arc sine of this decimal here. And remember, it has to be a fourth quadrant angle. See that? So we got to, adhere to this restriction. Let's just try this on our calculator. Make sure your machine's in degree mode. What would be the inverse sine of that decimal? Negative 0.3090. What is your calculator giving you, ladies and gentlemen? To the nearest tenth of a degree? Well, I'm getting like negative 17.99897619. So to round it off to the nearest tenth, one decimal place, that'd be like negative 18.0 degrees. But I got a question for you here. Why can this not be my answer? Why can I not settle here for as this being the answer?
Because it doesn't fall between 0 and 360 degrees.
Exactly. Notice the instructions. The instructions specify that our angle we are to find has to be a positive angle that lies between 0 and 360. So, ladies and gentlemen, we're not done. We need to go further to answer this question correctly. We know, however, that a negative 18-degree angle in standard position finds itself in what quadrant here? It's down here, ladies and gentlemen, in the fourth quadrant. So that would be like a negative 18-degree angle, let's say. Okay. But ladies and gentlemen, we want the positive angle for an answer. So we need an angle that is coterminal to this angle. That would be this positive angle here. So what angle is coterminal to negative 18 degrees and also lies in the fourth quadrant? What would this coterminal angle have to be? Well, we'll call that theta.
342.
Yeah, so theta is going to be like 360 degrees backing off 18 degrees. So 360 degrees minus 18 degrees. And you got, what was that, 342?
Yes, sir.
42 degrees. There you go, ladies and gentlemen. So that's your answer. So the sine of a 342 degree angle would give you this decimal, negative 0.3090. Now notice it's a positive angle and it lies in the fourth quadrant. So just because, you get on your calculator, your machine's going to give you an answer, but that answer may have to be tweaked to conform to the instructions or the demands that are being, put forth. Maybe we could try another one. That one make any sense there? Whoops, sorry about that. I knew that right. So 342 degrees would be the answer. And if you take the sine of 342 degrees, convince yourself you do get this decimal, negative 0.3090. All right, that one's good. Same instructions. If the cotangent of some angle theta is equal to negative 1.3862, and we are instructed that theta is to lie in the fourth quadrant, they want us to find theta. So we have to find the angle theta whose cotangent is this decimal, and that angle theta had better lie in the fourth quadrant, and it has to be a positive angle between 360 and 0. Now we don't have an inverse cotangent function on our calculator, so the first thing we need to do is realize that the cotangent of theta is really 1 over the tangent of theta, which is to say then it's this negative 1.3862. So what we now know is 1 over the tangent of this missing angle theta is equal to this decimal, negative 1.3862. Taking the reciprocal of both sides of this equation brings the tangent of theta up into the numerator. So the tangent of theta is 1 over negative 1.3862. Now, ladies, I'm going to find theta. We take the inverse tangent of both sides of this equation. So we take the inverse tangent of the left side of our equation and take the inverse tangent of the right side, which is this guy right here. The left side reduces down to theta, and the right side is going to be what? To the nearest 1/10 of a degree. So let's get on our calculator and see if we can, negotiate this. So we have the inverse tangent of 1 divided by negative 1.3862. And to the nearest 1/10 of a degree, what are we getting? Anybody? I'm getting like negative 35.8 degrees. Anybody else get that? Anybody else get that there?
Got that.
But this cannot be our answer because our angle theta must be between 0 and 360. So if you graph this angle very quickly, negative 35.8 degrees would be an angle in standard position. That's in the fourth quadrant. We need the angle that's coterminal to that angle. And so therefore our answer theta, well, I'm calling this theta up here. Maybe I'll call this theta prime or something. So therefore our answer, ladies and gentlemen, theta is going to be equal to 360 degrees plus theta prime. So theta is going to be 360 degrees plus negative 35.8 degrees. So our answer theta is going to be what? 360 minus 35.8, which would render us 324.2 degrees. 324.2 degrees would be our answer, and we are done with that problem. Okay. So again, when you take an inverse trig function of a decimal, it's going to give you an angle, but you got to be careful and make sure that you cite your final answer that adheres to the instructions that we are being bound by. Okay. So the final answer to this problem is 324.2 degrees. If you take the cotangent of this angle, it should give you this decimal here. Should give you that decimal back. So not only are we running into the reference angle thing in this section, which is the biggest issue, of course, the new thing we never knew, but we're also bringing back to memory our coterminal definition of angles, because there's times when we have to find coterminal angles. Now, so far, the trig function of an unknown angle has been a messy decimal. Sometimes, ladies and gentlemen, it will be a recognizable ratio, of which we will not even really need to use our calculator. to find the missing angle. Let me show you an example of what I'm talking about next. Do we have this down here? Are we good on this?
I got it.
Okay. Good. Let me show you what I'm talking about. Suppose if the cosine of some unknown angle theta is equal to the negative of the square root of 3/2, and we know that theta is to be a third quadrant angle. They want us to find theta. All right. Ladies and gentlemen, I got a question for you. When you see the ratio negative square root of 3/2, what triangle are you thinking of? The 45-45-90 or the 30-60-90? Anybody?
30, 60, 90.
Exactly. I mean, when you see the square root of 3, you should be thinking 30-60-90, because in general, remember how our 30-60-90 went? We had square root of 3, we had 1, 2 in general. Do you agree? When you see square root of 3, you should be thinking 30-60-90. If you see the square root of 2, you should be thinking what triangle? You should be
45, 45, 90.
exactly. When you see the square root of 2, ladies and gentlemen, that's a clue into thinking the 45-45-90 triangles in play here. Okay. So look at, we're thinking 30-60-90 triangle. So you know what? This angle theta has to either be the 30 or the 60 degree angle. Well, I'll tell you what. Remember this back here, ladies and gentlemen? All right. So the cosine of what angle gives you the square root of 3/2? The cosine of what angle gives you the square root of 3/2? Oh, that's this one, which is 30 degrees. So the angle is 30 degrees. But ladies and gentlemen, we can't say 30 degrees for theta because our angle has to be a third quadrant angle. Careful. Our answer is not 30 degrees. No, that 30 degree angle, ladies and gentlemen, would be in essence a reference angle to the angle we need. Wait a minute, wrong. Has to be in the third quadrant. The angle has to be in the third quadrant, not the second quadrant. All right, so, but that 30 degree angle, ladies and gentlemen, is going to be a reference angle to the angle we need. And the angle we need is going to be this angle right here. That's going to be our angle theta in standard position, a third quadrant angle. So what would this angle have to be if this 30 degree angle, as it turns out, is our reference angle?
210.
210 degrees. And so we're done. So theta is equal to, 210 degrees. We're done. We did not even need a calculator. We did not even need a calculator to answer this question. Notice. Because this ratio here lended itself to a nice triangle, namely the 30-60-90 triangle. And we also will have this handy. Do you agree? And knowing that the cosine of a 30 degree angle renders the square root of 3/2 ratio. But because this ratio is negative, ladies and gentlemen, as it has to be, because our angle theta has to be in the third quadrant. All right. That's why you got the negative sign that precedes this ratio, because we're in the third quadrant here, and the cosine of a third quadrant angle is negative. But we use the 30 degree angle then to negotiate what our third quadrant answer had to be, which is 210 degrees. And there's your answer. Okay. All right. So that is that. So what we have been introduced to in this section is something called the reference angle. And every angle has a reference angle in the XY plane. That reference angle might be one of our nice angles, either, the 30, the 45, or the 60 degree angle, or it might not be. All right. Whatever the case is, regardless, every angle, ladies and gentlemen, positive or negative in standard position, possesses a reference angle. Okay, this is your classwork for today. There are 3 questions. It is July 14th. I cannot believe we're like halfway through July. It's mind-boggling how fast our summer is going. Problem number 1, I want you to draw in standard position and name the reference angle and show on a graph. So the angle in question is negative 390 degrees. I want you to draw the angle, -390 in standard position, and I also want you to indicate or draw the reference angle to this angle. Number 2, find the exact value of the tangent of 480 degrees. Notice exact value. I don't want any decimals. I don't want you to jump on your calculator and do this. Number 3, I want you to find theta. If the sine of theta is -√3/2, and theta is to be a third quadrant angle. Give you time to work on that. 3 questions for classwork today.
Um, 30 degrees.
At 30 degrees. All right. -390 degrees in standard position is going to be one complete counterclockwise rotation. That's -360 plus another -30 degrees. So that pushes the angle's terminal side into the fourth quadrant. Well, therefore, ladies and gentlemen, the reference angle to this -390 degree angle, which is a fourth quadrant angle, is going to be this little positive angle formed by the terminal side and the x-axis. And to find the measure of this angle here, the difference between 390 degrees and 360 degrees is 30 degrees. So the little reference angle here will be 30 degrees for the -390 degree angle, 30 degree angle there. For number 2, the angle has to be what? I'm sorry, what is the tangent of 480 degrees? Well, 480 degrees finds itself in what quadrant? In standard position. 480 degrees is one counterclockwise trip around, which is 360 degrees, plus another 120 degrees, which forces the terminal side into the second quadrant. And so 480 degrees is 360 plus 120. But what's an angle that's so 120 degrees and 480 degrees are coterminal to each other. So 480 degrees and this 120 degree angle are coterminal angles. Now, what would be a reference angle to 120 degrees? Well, that's going to be, since it's a second quadrant angle, it'd be 180 minus 120, which is 60 degrees. So the tangent of 480 degrees is really going to be the negative. Why? Because it's a second quadrant angle, and the tangent is a negative ratio in the second quadrant, the negative of the tangent of 60 degrees. You can even build your 30, 60, 90 triangle, reference triangle. This is 30 degrees. This is your little reference angle of 60 degrees. Square root of 3, this is -1, and this side's of length 2. Tangent is opposite over adjacent, so square root of 3 over -1. Square root of 3 over -1. So the answer should be what? That's not correct. It should be just negative square root of 3. Did anybody get negative square root of 3?
Yeah.
Negative square root of 3. That's it. Opposite over adjacent side. That one's done. And number 3, the angle in question would be, as it turns out, 240 degrees. If you take the inverse sign of negative square root of 3 over 2, you get negative 60 degrees. But your answer cannot be negative 60 because our angle has to lie in the third quadrant. Negative 60 degrees is in the fourth quadrant. The bottom line, ladies and gentlemen, is this negative 60 degrees, you can do away with the negative sign and just think of the 60-degree angle as being like a little reference angle to our third quadrant angle. So if 60 degrees is a reference angle to our third quadrant angle, what would be the third quadrant angle? Well, it would be 180 degrees plus 60. 240 degrees should be your answer. That would be the angle we want to find for problem number 3. All right. So that's your classwork for today. As always, get that to me by midnight. I will get together the chapter 1 and 2 exam. Please get that back to me by midnight tomorrow night. By midnight tonight, please get the chapter 2 quiz. And I will email you, ladies and gentlemen, indicate to you what specifically I want you to send me as proof of your chapter 1 and 2 homework. Okay? Please get that also to me by midnight tomorrow night. All right.
Thank you, Professor.
All right. You have a great day. I'll stay on
You
the
too.
line if there are any other questions or concerns.